Hello and welcome to this Edexcel Further Statistics 1 video looking at further probabilities from the geometric distribution. In this video we're going to look at some more difficult problems, and it may be worth your while pausing the video at this point just so you can read through the problem and the information given to you in the first two paragraphs at the top of this slide. And the first question to pose yourself is, how can the situation given to you be modelled by a geometric distribution? So we need to identify P, the constant probability of a success, and X, the random variable. So in this case the probability of a success is actually the probability of observing a defective product, and X, the random variables, is the number of inspections necessary in order to find the first defective. So as good practice, always identify the parameter and the random variable and write down what they represent. So we've set up the model. It's now time to read through the question that's been asked that we need to find the answer to. And we need to read through the second paragraph of this question, and we need to turn the words in that second paragraph into a mathematical statement, and we need to then solve what we have written down. And again, you might want to pause for a moment and just think about that yourself. What we're really being asked to find is a value for our random variable little x, so that the probability of being less than or equal to that value is greater than 0.75. And that's quite an awkward inequality to set up and to realise that that is how we're going to solve the problem we've been asked to solve. So how could we go about solving this inequality? Well, we could try some values for x, and at the top of this slide I've worked out the probability that x is less than or equal to 3. So for our model I've evaluated the probability that x is 1, 2 and 3, added them together and got 0.488. So clearly 3 is not the solution, and the solution needs to be larger than that. We could carry on trying different values of x until we found the first value for x where that probability exceeds 0.75. If you have access to Geogebra, it's quite a useful activity just to plot cumulative geometric probabilities for p equals 0.2 on Geogebra, and it's then at that point very simple to identify where the cumulative probability first exceeds 0.75 and then to read off the corresponding value for x. Obviously this isn't a method you can use in the exam. So Geogebra can't be used in an exam, and we don't necessarily perhaps want to do lots and lots of calculations to solve the inequality. So what we can do is what we looked at in the previous video: consider the equivalent or the opposite end event, and rather than looking at the probability that x is less than or equal to a value being greater than 0.75, we can look at the probability that x is greater than x must be less than 0.25, and these two inequalities are equivalent to each other. And again, it might be worthwhile just spending a couple of moments just thinking about that. So if we now try to solve this equivalent inequality that we found, the probability x is greater than a particular value must be less than 0.25. Again, if x must exceed a particular value, we must have had that number of failures up to that point. We are going to need to have more than x inspections if we've already had x failures at finding a defective product. So that's equivalent to 1 minus p to the power x is less than 0.25. P equals 0.2. So we just have to solve the inequality 0.8 to the power x is less than 0.25. That could be solved by taking logs. Just be mindful of the change of inequality sign because when we divide by log 0.8 we're dividing by a negative quantity. And if we solve that, we end up with the inequality x must be greater than 6.2. So 7 inspections are necessary as we identified on the Geogebra cumulative probability plot. So that is the end of this video. The next video will look at the mean and variance for the geometric distribution.